All right, Markovnikov's rule of addition. The carbon with the least number of hydrogens will form what we call a carbocation. In this case, in 1-butene, this is carbon number 2 because carbon number 2 is a secondary carbon, meaning that it has been connected to 2 other carbons, so second degree. The first carbon here is primary, one with a degree symbol, and that's where the new hydrogen will go. And on carbon number 2 is where the halogen, in this case chlorine, will go. And the reason for this is because carbon number 2 will form a more stable carbocation because it's surrounded by more electronegative elements. So wherever you can form the most stable carbocation, which is going to be the one that's more in the center of the molecule, that's where you're going to add your halogen. So double bond still acts like the nucleophile and attacks the hydrogen. The hydrogen gives its electron back to the chlorine. My intermediate looks like this. Carbon is going to now have the carbon attached to the hydrogen attached to the first carbon because it is the less electron shielded carbon. Does not have as many electrons around it, so it's not going to form a stable carbocation. On the carbon number 2, you'll have a positive charge because it has left and it's stabilized by the CH2CH3 group that's left behind. All those electrons are stabilizing it. It's attracted to that. And there's the additional hydrogen. My new nucleophile will be this chlorine that has the negative charge. It will attack the carbocation. And so I'm going to make 2-chlorobutane. Cannot make 1-chlorobutane because the chlorine will not attach to a primary carbon because that carbon's not going to form a stable carbocation. So that is what you're going to form. One of the IB questions that you would be asked, something like this: which carbon would the chlorine most likely attach to? And you always look for the carbon that is surrounded by the least number of hydrogens or the most number of carbons. That is Markovnikov's rule.